Let's solve this LeetCode33 question, search in rotate sorted array. So in this question, basically give you an array, and then we found a pivot. Let's say here is the index 3, and then we rotate. Means like we swapped the two array based on the pivot. No, the one array based on the pivot. So it's become like this: 4, 5, 6, 7, 0, 1, 2, and then give you a target, and then you search from this array if 0 is in the array or not. If in the array, return the index of 0, this target is 0, or return -1. So if the target is not in this array. So okay, see, let's this question we can see it's asking you must write an algorithm with O log n. This is time complexity. So whenever we saw O log n, we can think about binary search. Okay, so actually we can iterate from this question. We can start check this one if equals target, check this one, check this one, check this one, but the time complexity is O n. But here we are asking O log n, so we use a binary search. We can notice that this is the pivot, so we can see the left part of the pivot is exclusively greater than the right portion of the pivot. So this part is greater than this part. So we can see in this array, there's a two portion for array. This is the left portion of the array. This is the right portion of the array, okay? Let's put it here. And we can see the two sorted arrays, the left portion and the right portion. We can see they are actually independently sorted, okay? So they are independently sorted. Okay, also in the binary research, we know that we have kind of a three-pointer, left, middle, and right. Okay. Okay, so let's say the middle of this array is 6. Okay, let's do this way. So this index 1, 0, 2, 3, 4, 5, 6. Okay, let's say the middle is 6. Okay, so when the middle is 6, that means that and then we check the target value. We check the target value is smaller than the 6 or greater than the 6. So if the target value is smaller than the middle value, that means the target potentially can be in this side or this part, right? So and then in this case we have to check the leftmost, the value of leftmost. So if the target value is smaller than 6 but greater than the leftmost value, then that means the target is around here. So now we don't know the target. The target is not 0. Okay, so I'm giving the example. So we got the direction of the binary search will be on the left. So we're gonna eliminate all this part, right? So because we checked this one and this one with the target value, so we know the target value is here. So, or the target value even smaller than the 4, that means the target value in this side. So in this case, we just check from the middle to the right. Okay, so basically the algorithm, actually we are just trying to Okay, so basically we are just looking for the direction of the binary search. So yeah, the direction of the binary search. So okay, 1 second. Yes. Yes. Okay. So and also if the target value is greater than medium, that means the target value, we will do the binary search from here, and then we eliminate this part. Okay, so this example is when the middle value in the left portion. Okay, this one is in the left portion. Okay, so what about what if the middle value in the right portion, let's say, is in the, let's say, if the middle value is here, and then we check the target greater. If greater than the middle value, that means that it probably be in this part or this part, right? So, but we have the rightmost the element. We will check the rightmost element is greater than target or smaller than the target. If the rightmost element greater than the target, that means, and also greater than the middle, no, smaller than the middle, that means it will be this portion. But if the target is smaller than the middle, then we will search this portion. Okay. Okay, so basically, what we do, we need to decide is in the left portion or the right portion, and decide more, and determine that. So there's two cases. One case is the middle value belong to the left portion. Another case is belong to the right portion. Okay. Also, how to determine the target is in the left portion or right portion. So so we normally do we kind of compare if the left most value smaller than the middle. That means that this part, the middle is in the left portion. Middle is in left portion. Otherwise, the middle in the right portion. Okay. Okay, let's start the coding. Okay, here is the corner case. Okay, if names equals to none, or names dot length equals to 0, then we return -1. That means there's no target. That means, yeah, this a corner case, and then we initialize the left equals to 0, and then the right equals to names dot length -1, and then what we will do, well, left +1 smaller than right. Okay, in the middle equals to left plus right. And this the middle equals target written middle. Okay, so we check the middle, if it equals to target, we just return the middle. That's the index. Or if not, then we will check numbers middle. If numbers middle greater or equals to left, then that means that we are in the left portion. Okay, and then we check the target greater than nums left and the target. And 1 second. Smaller than nums the middle. And then what are we gonna do? We're gonna update the red pointer. Okay, we're gonna update the middle to the red pointer. Else, otherwise, we're gonna update the left. Or else, if target similar equals to nums, here's right, or the target greater than nums middle. Or the else, we update the right pointer. Okay, this is a while loop. Okay, after the while loop, what we do, we check if the numbers left equals to our target. If it equals to our target, then we return here. We just return the left. Or otherwise, we're gonna return numbers right equals to target, otherwise -1. Okay, let's check. Let's check this one. Let's run this code. Okay, accept. Okay, so our code runtime is 1 ms faster than 63% of Java online the one. So the time complexity for this problem, the time complexity for this problem is big O log and because we use binary search, and the space complexity is actually 1 because we don't use any other extra data structure. We're just using the binary search. Okay, we put it here. Okay, thank you for watching. I'll see you next time.